the interval for a specified number of periods. Okay, so we can solve this question by using just your hand, right? So for example, manually 1, 2, 3, 100, 100, 100. We want to get the value of all cash flow as of year 3. That's the future value of annuity. Okay, so you are here, you are at the end of third year. So as of year 3, how much money we will receive? That is the future value of annuity. Okay, so the amount that we will receive on 100 at the end of third year is the 100 at the end of third year, right? How about the 100 at the end of second year? It's gonna be 100 times 1.1 because we should consider time value of money, right? So $100 that I expect to receive at time 2 is gonna be 100.1 as of year 3. Okay. How about this 100 that I expect at time 1 is gonna be 100 times 1.1 square as of year 3. So future value of annuity is the sum of these 3 cash flow stream. Okay, so 100 times 1.1 is 110. 100 times 1.1 is the 121, right? So the sum of these 3 cash flow stream is gonna be 331, right? So the answer is 331. So we can calculate this one by using those kind of a manual method if this, the year is only 3 years. But how come? What happened if year is 100 years? Or if we compound on every month, then 1 year has 12 months. Okay, so if the cash flow occur every month, not year, every month for 10 years, then we can have to calculate how many equations, 120 equations, right? It's possible, but very time consuming work. So we need to use the formula, just like this formula, okay? So we can generate formula to calculate the future value of annuity. How come? Okay, for example, this is if the maturity is 3 years, then the first term is payment times 1 plus I to the power of 0. This one, right? 100 is payment. 1 plus I to the power of 0. 1 plus I to the power of 0 equals 1, right? So this cash flow stream is expressed by payment times 1 plus I to the power of 0, right? And next term is what? 100 times 1.1. How can we express this equation? Payment times 1 plus I n to the power of n minus, for example, this is 3 years, then n minus what? n minus 1, right? n minus 1 is 3 minus, no, n minus 2, n minus 2, n minus 2, right? If the maturity is 3 years, we don't have to think about this one, right? So there are 3 terms, this one, and this one. This one is the $100 we receive at year 3. This one is $100 at year 2. This is 101 the amount that we will receive the first year, right? So this is 100 times 1.1 to the power of 0, 100 times 1.1 to the power of 1, n minus 2. N minus 1 is the payment times 1 plus I to the power n minus 1. So if n equal to 3, then it's the payment times 1 plus I to the square plus payment 1 plus I plus payment itself. This is 100 times 1.1, 100 times 1.1 square that I did, right? So we can generalize if maturity is 3 years, then we can consider the n minus 1 as an exponent for the as the first term. Okay, so we can generalize cash flow stream to calculate the future value of annuity. This cash flow stream can be expressed by this equation. How come? How come? There is the formula to calculate those kind of equation. What is called? I bet you learn this one in the high school in mathematics class. Most of you guys hate mathematics, right? No? Yeah. Okay. So what is called the formula to calculate those kind of equation? 준서. Oh, 준서. 네. 준서. 네. 준서. 네. My name is 준서. Yeah. 준서.
Yes, Professor.
Yeah. What is the name for formula to calculate this kind of equation?
Formula.
Formula. Yeah. So this formula. 식. So there's some pattern, right? There's some pattern. Let me explain more. There's some pattern, right? So first term is payment. Second term is payment times 1 plus I. Third one is payment times 1 plus I square. For example, if the maturity is 3 years, okay? So there's the formula to solve this kind of equation in easy way. So this pattern, right? What is pattern? If we first term times 1 plus I is gonna be second term, right? Second term times 1 plus I is gonna be third term, right? So what is called this kind of 1 plus I? Common ratio. 공비 in Korean. 공비, 무장공비, 부다다다닥 무장공비, 공비 in Korean. Okay, so there's some equate term to get the second term from the first term, right? So the first term times something is gonna be second term times something is gonna be third term times something is gonna be fourth term. But the something is the identical number, identical figure. So this kind of identical figure is called as common ratio, 공비 in Korean. So this one is what? 초항, initial term. So if equation has this kind of the pattern, then we can calculate this kind of equation by using what? Sum of finite geometric series. In Korean, 유한등비급수의 합. You've heard about it, right? 유한등비급수의 합. Sum of finite geometric series. So how can we figure out the sum of finite geometric series? S. The sum of finite geometric series is called A plus AR squared plus AR to the power of n minus 1. Right? In this equation, A is initial term, R is the common ratio, right? So to figure out the sum of finite geometric series, we can take the R in each term in equation 1. Then if we multiply equation 1 by R, then R in each term in RS equal to AR times AR squared, AR to the power of 3. So the last term is AR to the power of n, right? So if we equation 2 subtracted by equation 1, then 1 minus rs equal to, except a minus ar to the power of n, other terms are wiped out, right? ar minus ar square minus ar square, ar to the power of 3 minus ar to the power of 3. All of equations wiped out except a n ar to the power of n. So a minus ar n remains. Okay. So rearrange, if we rearrange, this one is s equal to a times 1 minus r to the power of n divided by 1 minus r. This is the sum of formula to solve sum of finite geometric series. Okay, and that example, okay, so s equal to a 1 minus r to the power of n divided by 1 minus r. In previous example, what is the first term? First term is, I already let you know, right? Paul,
Yes.
what is the first term? What was the first term in the previous example? What was the a? Previous example, generalization form.
The A is the amount of the annuity, right?
Yeah, payment, right?
Yes, payment. Yes.
Yeah, payment is a. What is the common ratio? What is the common ratio, Mark?
It's
What kind
10%.
of term? Yeah, what kind of term to get the second term from the first term? Mark, what is the common ratio? 1 plus?
I don't know. I'm trying
You
to
don't
understand
know?
it.
Yeah, I already explained the common ratio in this previous example. So common ratio is 1 plus I. Common ratio can be defined as some term to get the second term from the first term, right? So first term is payment, second term is payment times 1 plus I, third term is payment times 1 plus I square. So to get the second term, which is the payment times 1 plus I from the first term, payment, then we can get the payment times 1 plus I. How come? Payment, which is first term, times 1 plus I. So 1 plus I is going to be the common ratio, right? So if we, substitute this, the figure on this equation, then a equal to payment, 1 minus r equal to r 1 plus I to the power of n divided by 1 minus 1 plus I, right? We rearrange this equation is payment times 1 minus 1 plus I to the power of n divided by 1 minus I, right? Minus I. So if we take the minus, then payment times minus wiped out 1 plus I to the power of n minus 1 divided by I. We figured out this equation. This equation is called as future value